So, hello everyone, and welcome to my talk, Higher Order Observables and Operators in RxJS. I will start by introducing myself for those who don't know me. My name is Lamis. I'm a technical expert here in Tunisia, working for Vermeg. I am based in Tunisia and I'm a GDE for Angular. I'm also the author of Reactive Patterns using RxJS with Angular book, which was picked as the best new RxJS ebooks like the last 2 months. I've been into Angular for the past few years. I'm the founder of Angular Tunisia, speaker, mentor, and a trainer. So, without further ado, let's start and jump into higher order observable. And I want to start with transforming streams, which is like the key behind the higher order observable stuff. So, the process of streams transformation is nothing but transforming a stream of values into a stream of other values. Okay, there's some transformation that we perform inside which transform the values emitted by the first streams into other values. Okay, and the first one of the first transforming operators that we started learning at the beginning was like the famous map operator, which transforms the stream of values of the input observable into a stream of other values after doing some transformation. Okay, so in this marble diagram, the transformation of the map operator is like multiplying the numbers or the emitted elements by 10 every time. The first line is the timeline of the input observable, and the second line is the outline of the output observable. So output observable is the observable after the transformation. Okay, so the first observable or the input one produced 1, it's multiplied by 10, it's the output is 10. 2, the output is 20. 3, the output is 30. So as simple as that. This is one of the most trivial cases uh, with the map operator. We can use also the map operator for more difficult, let's say, use cases compared to the previous one. So as you can see, this example is about retrieving some clients. Okay, we have a client API. It's an Angular-based example here. They're using the HTTP client in order to request the client's API, and we just like use the map operator in order to create another object from the emitted uh, client objects. Okay, so for every client received, normally it's an array of clients. So for every client received, we want to produce a client with some properties. Okay, imagine so you have the client returned has like 10 properties. You just want to keep 2 of them. So you just like use the map operator in order to construct your object with the properties you want to keep. Okay, so this is another example that we use in daily life. It's a simple one. Um, we can use the one of the transformation operators also because there's a list of many transformation operators in RxJS. It's not only the map one. We have here another example. It's the flag operator that we use in order to like pick one property of our response. Okay, so imagine we have a response that contains many properties. We just want to pick one, which is the payload. And like we can use plat in order to pick that property and return it. Okay, so It's about transformation again, because we transformed the stream of these values into other values. We can also like use the map operator here to do some calculations. Okay, so here we requested the API that returns a client, a specific client, by giving the client ID. And we just like, we retrieve the client and then we calculate if this client is eligible for a loan, for example. So we can use also the transformation operator for that case in order to like retrieve and do some calculations. And the examples, use cases for that are really endless. But so this is the goal behind the transformation. But again, here is an example of like a transformation um, of events. Okay, so the DOM events, click events into other objects. And as I said, the examples are useless, but observables don't always um, return simple values like strings, numbers, okay, and simple data types. Life isn't always easy, and it's not like always about processing simple cases. In sometimes, and surprisingly often, we have to deal with observables of observables. Okay, so the value or the output emitted by one observable is an observable in itself. Okay, it's not only about simple data types. And here we can speak about higher order observables. Okay, so this is the definition of higher order observable. It's an observable that produces other observables. Okay, so here we have like an observable of values. This is the timeline of the inner observable. And for every emitted value, we have an output observable. So which is called, so the first one is called the outer observable, the produced one after every emitted values. After every emitted value is called inner observable. Okay, so this is the spirit behind higher order observables. So for now, it may seem like a little bit complicated, but don't worry, we will like demystify this little by little in this course. So here I want like to focus on a concrete example or concrete or real use case of of observables. Okay, so here is the autosave feature. Okay, sometimes, or there are two like types of saving some of saving entities. We can choose to like do the save automatically without like putting a save button, and the user will not like manually do it. So we have here a form. It's a client form. It's just an example. There are a few fields that the user have to input, and the system should do the autosave of this form automatically behind the scene. Okay, so if we break this down, we can again here rely on an Angular implementation. I will like use Angular in order to implement this. So here we can like build the form using Angular forms. And when we use Angular forms, like we have the property value changes, which is available inside the form in itself, and that returns every time it, it's an observable that emits every time the recent value of the form. Okay, so we'll have the recent value or the recent input, the recent user input in this form. So here, like I stored the value of value changes, which is the observable, in the value changes dollar observable. Okay, so dollar is convention. For those who don't know, it's a convention to point an observable. So here we have the value changes observable that emits every time the newest or recent value of the form. For every recent value, I want to save it. Okay, so I want to save this form value in order to perform like a kind of automatic save. So what will I do? I will subscribe to the value changes dollar in order to get the most recent value and call the API, which is responsible of saving the entity. In my case, it's the save API, and that takes as input the form value that I just posted. And again, here in Angular, the HTTP client returns an observable. So the output of this dot HTTP that post is an observable in itself that I stored in save client dollar, which is an observable. So here, what will I do? I will subscribe logically. I will subscribe to the value changes dollar for every emitted value, which of the value changes dollar, I will just perform save client dollar. Okay, so I will output, let's say, the save client dollar. So this is the higher order observable use case. I mean, for every emitted value we are producing an observable, this is higher order code. So this is the real case of it. Okay, for every value I want to perform an HTTP request, which is an observable in itself. Yeah, so it's the case is very like recurrent. We can use it in many situations, and yeah. So how can we like okay, we know how we are going to uh, implement this, the algorithm if you want. I will subscribe and then like output the save client dollar. But how we can like in order to get the data of the save client dollar, we should subscribe to it. True or not? That's true. So so how we will subscribe to it inside the observable on itself, how we will unsubscribe to it again, how we will like retrieve the values, and yeah. So what's the relation between them? How we will manipulate it? So here where the operators come into place. Okay, so in order to manipulate higher order observables, we need a special type of operators, which are called the higher order mapping operators. Okay, so here the higher order mapping operators has or have, sorry, three main goals. They map values from outer to inner observables. Okay, subscribe to inner observable and unsubscribe to inner observables. That's what we want. Okay, so it's that's okay. That's simple. We will output an observable, but how we will subscribe to this one? We are only subscribing to the outer observable normally, and how we will do the unsubscription, how we will do the transformation. Okay, so those 3 points are fixed by the existence of the mapping operators. I will walk you through most used higher order mapping operators throughout this session. We will start by the Concat Map, which like I split this down into two words. It's the Concat plus map. So Concat Map, it's the combination of the Concat strategy plus the map, which is the higher order mapping. Okay, so we will like focus on the concat strategy and then add the higher order mapping stuff and see how this will work. So let's start with the concat strategy, and to explain the concat strategy, I will like present or explain the concat operator. Okay, so the concat operator, it's about concatenating two observables, or it's not two. In this case, it's two, but it's more than one observable. So here in our case, we have two. We have the first observable, the second one, and the first one is emitting value. So the first value emitted by the first one is the value one. So the concat will like output one. Then the second value, then at the same time, if you want, the second observable produced the value two. Concat will put this observable as standby, okay, because he's processing an observable currently. Okay, so the concat map will output the second value of the first observable, which is one. Will then output the third value, which is one again, and then the first observable completes. So at that time, the concat operator will process the values of the second observable and will produce the values of the second observable one by one. So as you may have noticed, the second observable completed here. So it completed like before the first one, but it doesn't matter, and started producing elements as at the same time of the first one. But concat operator doesn't care. Okay, concat operator will like process the elements one by one, and the order is very important. Or the first in, the first out. Okay, so the first observable started, concat operator will like process the values of the first observable and then process the values of the other observables waiting in the path. So yeah, so it's concat strategy is about order. Okay, the values will be treated and the observable will be treated sequentially. Okay, and it's about observable completion. When the first one completed, it will start to process the values of the following one, and so on and so forth. So this is the concat strategy. This is how concat works. And if you combine it with the concat map, okay, so it's like concat map is about combining the concat strategy with the map, which is about transformation. Okay, so higher order mapping, and we call it higher order mapping because it deals with observables. So here you can see that okay, the concat here processed the values of the first observables, did the transformation or executed the transformation function inside the concat map, and output uh, the values of both of the observables sequentially. Okay, so this is what concat map will how concat map works. So it's about order, observable completions, and uh, it treats things sequentially. So here, I think that we can like use the concat map in order to fix the real use case that I show you, which is the use case of the autosave. Okay, so for the autosave, really, it's about like sequences. Okay, so it's about order also. Every recent value, okay, so for every recent value, I want my system like to set to persist this value in my backend, and I want like to treat values one by one. So here with the form value changes, this is observable. We will use the pipe in order to combine operators. We will then use concat map. And for every incoming value, we will call this observable, which is the HTTP post API client, and that takes as input the form value. Um, Here we are subscribing to the output observable and just showing a message of success when the save is performed successfully. Otherwise, it's an error. Okay, so the concat map here will do the transformation and will automatically subscribe to the post one. Okay, so you know that without subscribing to the HTTP post observable, you will not get anything, right? So here there is no nested subscription. Why? Because concat map did this for us. Okay, hopefully. And yeah, the subscription, the unsubscription, the transformation, and she processed the values of the observable sequentially. Okay, so this is the how concat map works. Now let's go to merge map. So merge map is about combining the merge plus map. Okay, so the merge strategy plus the map, which is the higher order mapping operator. So let's focus on the merge strategy in order to understand it. If we understand the merge strategy or the strategy in itself, you will understand the operator automatically. So here the merge strategy is about like merging the values of the input observables as soon as they come. Okay, so here suppose we have two observables as input, which are represented by the first timeline, the second timeline, and yeah, so the first observable emitted 20. So merge map will like output this value automatically. Its output. So here we have 20 as output. Then 40, which is emitted by the first observable. 40 is emitted. 60 again, it's emitted. Now at that time, the second observable, which is represented by the second timeline, produced the value 1. Okay, so merge map will automatically emit this value as output. Then here, the first observable emitted 80 is here. It's emitted as output. 100 as well. Then here 1, and it's so the values emitted by the observables are treated as soon as they come. Okay, it's not like the concat. The concat, like when the concat operator is focused on one observable, it doesn't look at the others. So even if the values came, meanwhile, it will like put them in standby, complete the first observable. When the first observable complete, it started like to look at the others one by one. For the merge map, it's not the same thing at all. Merge map doesn't care. The order is not important. The values are treated as soon as they come. So this is the merge strategy. And it's very useful when the order is not important and we are interested in all the values. We don't need to do a sequential processing. Okay, so yeah. So here's the difference. And yeah, combining this with the map, which is the higher order transformation operator or mapping operator, yeah, you will get this. So this is the marble diagram of the merge map. Like here, we are just combining the merge strategy and executing the calculation function. Okay, and the values are emitted as output as soon as they come. Now another operator, which is the switch map. This one also is super famous, and it's the combination of the switch strategy plus the higher order mapping map. And if we look at the switch strategy, so here I have the marble diagram of the switch all. We can like look at this marble diagram in order to understand the switch strategy. So here, so every emitted, so the first timeline is the timeline of the first observable. Okay, this is the outer observable, and those are the inner observables. So the outer observable is producing inner observables. So two inner observables. So for the switch, like for the first value, which is A, it's the value produced by the first observable, the switch will emit it as output. The second one, it will emit it. Now, for the third one, and for the third one at the same time, there is the second observable emitted the value E. Okay, so it will switch to the second observable automatically and will produce the value. Yes, it will ignore the value emitted by the first observable. Okay, because this is the switch strategy. It's about like when another observable starts uh, emitting values or most recent value, we need to switch because this value is maybe um, more relevant for us. Okay, so it will switch directly to the second observable. It will emit E, F, and then so C and D are ignored because yeah, at that point the switch ignored the first observable. Okay, so yeah, so this is the switch strategy. When you are interested in the most recent value, you don't care about I mean the current one or the values emitted by the first one are not relevant when another value when most recent value hits the scene. Then yeah, you can use the switch strategy in order to use one of the operators of the switch strategy and like do this yeah, the switch and ignore the first one. And if we combine it with the map, like yeah, we just add the execution of the function as input, and we just like emit the result as output. Okay. The following operator, which is the last one, I picked like the four used ones, most used ones. It's the exhaust map, which is again the combination of the exhaust plus map operator. And for the exhaust map, it's very close to the switch, but with a small difference. So here, consider we have three observables. Okay, the exhaust will start by the first one, which is the first one that emitted a value. So we will start by it. It will emit A, B, C, but at that moment, there is another observable that emitted values. Okay, the second observable starts emitting. So it's not so unlike the switch, it will not like ignore the first one and switch to the second observable, but it will like continue processing the first one. It will emit C, and then the first observable completes. Okay, so unlike concat, again, it will not like come back to this one, to the ignored one. Concat will like put it as a standby and come back to it. Exhaust, no, it doesn't work that way. It will like ignore it. Once it's ignored, well, it's ignored forever. And here it will no longer look at this observable. Okay. So what happened after this completion? After the completion of the first observable, there's a value f as this observable is ignored. So yeah, has died, and for exist map it does not exist anymore. And then after that, there is a value which is emitted to the value j. Okay, so yeah, so at that moment, exhaust is free, so it can start emitting and to emit the values of the third observable one by now, as you can see here. So when another observable hits the scene while exhaust is processing the values of a current observable, it will ignore it. But this one will get ignored. It will not come back to it. But after the completion of the first of the current observable that exhaust map is currently processing, then it will if any other observable will like emit values to treat them. So this is the exhaust map. And if you combine it with the higher order mapping operator, then it will look like this is the Marble diagram. And like you have here, it's the same output of the previous Marble diagram with the difference of the calculation function. Okay, to execute the calculation function. Yeah, so that's it. So in a nutshell, use Concat Map when the order is important and you want to, or you have a sequential process. So Concat Map is very important. All the values are important. All the observables are important, and the order is important. No one will get ignored. Use the concat map. Merge map, if you want to treat like observables in parallel and the order is not important and you want to gain in performance, yeah, and the order is not important for you, you want all the values to be treated, then use merge map. Switch map or exhaust map when you are switch map when you are um, when you want to put a cancellation logic. Okay, so you want if a recent value can you want to cancel the previous one because you are not interested anymore in that one in that value. You are interested in the most recent value. Okay, and you have so you want to cancel the current process and start a new one. Okay, so use switch map if you uh, have this use case. And exhaust map when you want to ignore new observables when you are treating observables currently. Okay, so use exhaust map. Yeah, so that's it. I have like a dedicated chapter for this in my RxJS patterns book about higher order operators and and the implementation of real use cases. Yeah, so you if you are interested, you can pick the book and uh, learn through those patterns. Thank you very much for your attention. Thank you for having me. It's been a while since my last talk in the MENA days. And if you have any question, don't hesitate to reach me on Twitter, LinkedIn, or email me. So thank you very much. And if you have any question, again, here now, I have 10 minutes in order to answer your questions. Let me just share with you. If you have any questions, just go ahead and ask here. So I will share with you my slides later. I will share my slides, and I will share with you the link of the So again, thank you very much for having me. And if you have any questions, don't hesitate to reach out. Thanks a lot. Bye.